All right, let's look at this question. This is all about Security Hub and avoiding installing agents on EC2. Option A, turn on Amazon Inspector and select hybrid scan mode for EC2. Link Inspector output to Security Hub for visibility. Inspector hybrid mode supports agentless vulnerability scanning on EC2 and publishes findings to Security Hub. Let's keep this. We'll move to B. B says activate the foundation AWS foundational security best practices standard inside Security Hub and let Security Hub generate insights. Foundational checks audit account configuration, not active software vulnerabilities within EC2 instance. Incorrect. We'll move to C. C says start guard duty malware protection for EC2 and connect its alerts to Security Hub to detect suspicious activity. Guard duty malware protection detects runtime threats but doesn't perform software vulnerability scans. Wrong answer. We'll move to D. D says use AWS config manage rules to assess EC2 for software risk and forward detected vulnerabilities to Security Hub. AWS config tracks configuration drift but doesn't scan for package level software vulnerabilities. Let's delete it. The lock option A is the right answer. Let's bring the heat to the snow. This will test your concepts on CloudTrail, S3 and IAM roles. We'll look at option A. A says update the S3 bucket policy to permit the third-party IAM role to perform decryption on encrypted log objects. S3 bucket policies control storage level access but cannot authorize decryption using KMS keys. Incorrect. We'll move to B. B says modify the KMS key policy to allow the third party IAM role to execute the KMS decrypt action using the customer managed key. KMS key policies must explicitly allow KMS decrypt for the provider's role to read encrypted data. Let's keep this. We'll move to C. C says attach the AWS key management service per user AWS managed policy to the third party IAM role to enable key operation. AWS key management service per user enables key creation and management, not secure decryption for external roles. Wrong answer. We'll move to D. D says move the KMS key into AWS certificate manager and expose it via a shared endpoint for the third party to access encrypted logs. Let's move to option D. D says move the KMS key into AWS Certificate Manager and expose it via a shared endpoint for third party to access encrypted logs. AWS Certificate Manager doesn't handle KMS keys, and migration to ACM, that is AWS Certificate Manager, isn't supported for this use case. Let's delete this. We'll lock option B as the right answer. Alrighty, now let's look at this question. This is about CloudWatch logs. We'll look at option A. A says set up Amazon Macy with a custom data identifier using regex that matches email formats. Macy detects sensitive content in S3, not in CloudWatch logs, what we need. And it doesn't mask log visibility dynamically for IAM roles. Hence incorrect. We'll move to B. B says generate a KMS key to decrypt data log data in the group. KMS encryption restricts access to the entire log data, not granular masking of individual fields like email addresses. Let's reject this. We'll move to C. C says add a CloudWatch logs subscription filter to forward logs to a Lambda function that parses entries and replaces email values before exposing logs. Lambda based filtering adds operational complexity and latency and doesn't scale for near real time developer access. Wrong answer. We'll move to D. D says enable a data protection policy on the log group and use the AWS managed email address identifier to mask matched values during log reads. Data protection policies in CloudWatch logs can automatically detect and mask sensitive data like email addresses using managed identifiers. That being said, option D is the right answer. Alright, now let's look at this question. This is all about a scenario where we have workloads across different AWS accounts. We'll look at option A. It says use IAM access analyzer to evaluate required permissions per account. Access Analyzer helps identify resource permissions but doesn't automate provisioning across accounts. Wrong answer. And move to B. B says built a workflow using Amazon SWF to let developers submit cross account access requests when needed. AWS or Amazon SWF is designed for workflow coordination and doesn't manage access permissions or scalability for identity controls. Incorrect. We'll move to option C. If you look at option C, using STS assume role with trust policies enables controlled, scalable, cross account access without disturbing long term credentials. Let's keep this. We'll move to D. D says create service accounts in testing and production, distribute access keys of these accounts to relevant developers, and periodically rotate credentials. Sharing service account access keys across developers increases risk and complicates credential management over time. Let's delete this. We'll look option C as the right answer. All right, now we'll look at option A now. E says set up an AWS trail, enable log file integrity validation, and turn on data event logging for Amazon S3 resource type. CloudTrail supports object level logging for S3 and includes log file validation using cryptographic digest and signature. Let's keep this. We'll move to B. B says create a dedicated Amazon S3 bucket and centralize S3 server access logs. S3 server access logs offers general usage records but lack object level operation details and digital validation capabilities. Incorrect. Let's move to option C. C says define an Amazon CloudWatch log group. CloudWatch logs doesn't support direct ingestion of S3 access logs, nor log file integrity validation mechanisms. Wrong answer. We'll move to D. D says launch a new S3 bucket to store server access logs with log file validation. S3 server access logs doesn't support digital signature validation even when stored in a separate bucket. Let's delete this. The lock option E as the right answer. Alright, now let's look at this. This is all about EKS cluster, guard duty, and it will test your concepts on Kubernetes as well, right? That is DevOps. Let's look at option A. E says activate VPC flow logs for the VPC where the EKS clusters are running. VPC flow logs support network visibility but doesn't provide Kubernetes audit or runtime context for guard duty EKS protection. Wrong answer. We'll move to B. B says attach the CloudWatch events full access AWS managed policy to IAM roles used by the EKS cluster. The CloudWatch events full access policy doesn't impact guard duties ingestion or monitoring of EKS cluster activity. Let's eliminate it. We'll move to C. C says confirm that the Amazon guard duty full access AWS managed policy is applied to the guard duty service role. The service role policy supports guard duty operation but doesn't activate EKS audit log ingestion. Wrong answer. We'll move to option D. D says turn on Amazon EKS control plane logging and route the logs into Amazon CloudWatch logs. EKS protection relies on control plane audit logs which must be enabled and ingested for guard duty to analyze Kubernetes activity. That being said, option D is the right answer. We'll look at. Alright, now let's look at this question. This is all about Amazon time sync service and CloudTrail. We'll look at option A. It says analyze CloudTrail logs for entries showing API usage involving non-stranded time services. CloudTrail records AWS API usage, not low-level outbound traffic to internet-based NTP services. Incorrect. We'll move to B. B says query CloudTrail logs to find EC2 instances making API calls to Amazon time sync service. Checking usage of Amazon time sync doesn't reveal violations or attempts to use external servers. Wrong answer. We'll move to C. C says inspect VPC flow log data to detect traffic patterns originating from EC2 instances going to external NTP servers. VPC flow logs capture IP level traffic, allowing detection of outbound NTP traffic toward internet hosts. Let's keep this. Let's move to option D. D says filter VPC flow logs for outbound traffic from EC2 instances communicating with the Amazon time sync service. Monitoring traffic to Amazon time sync service detects compliance use, not violations involving external NTP servers. That being said, D is out. We'll lock option C as the right answer. Alright, now let's look at this. This will test your concepts on RDS and AWS backup and as well as S3. We'll look at option A. It says configure AWS backup to tag RDS snapshot with a retention label indicating a 7-year lifecycle requirement. Tags alone doesn't enforce retention behavior. Backup lifecycle must be controlled via backup plans. Incorrect. We'll move to B. B says turn on versioning for the S3 bucket that stores RDS backup. Apply a bucket level 7-year lifecycle configuration. Versioning on S3 doesn't influence snapshot retention or integrate with AWS backup's backup lifecycle logic. Incorrect. We'll move to C. C says define an S3 lifecycle policy that enforces a 7-year retention timeline on objects placed in S3 bucket used by AWS backup. S3 lifecycle policies manage object transitions in S3, but AWS backup manages RDS snapshot retention independently. Wrong answer. We'll move to D. D says set up an AWS backup plan and configure it to keep backups for 7 years before deletion or archival. Backup plans allow AWS backups to retain and manage RDS snapshot lifecycle for exactly 7 years as required. That being said, option D is the right answer. Alright, now let's look at this. This is all about S3 buckets, and the situation here is that security policy mandates that no IAM principal from outside the organization should be able to access the buckets. Let's look at option A. It says activate block public access settings on every individual S3 bucket to limit external exposure. Blocking public access prevents exposure to anonymous users but doesn't restrict cross-organization IAM principles. Incorrect. We'll move to B. B says enable block public access settings across all AWS accounts to globally restrict internet exposure. Account level blocking limits public sharing but doesn't differentiate between internal and external organizational access. Will reject it. We'll move to C. If you look at option C, AWS resource org paths isn't valid in SCP. SCPs doesn't evaluate resource based organization paths, hence invalid. We'll move to now D. If you look at option D, matching principal org ID with resource org ID ensures only entities from the same AWS organization can access S3 buckets. That being said, option D is the right answer. We'll lock it. Alright, now let's look at this question. This is about AWS Security Hub findings and AWS Lambda. We'll look at option A. It says update the existing Lambda function to ignore any message originating from Amazon Inspector by matching event patterns. Adding logic to Lambda increases complexity and introduces unnecessary processing load. Incorrect. We'll move to B. B says configure a custom action in Security Hub that selectively forwards findings from services other than Amazon Inspector to EventBridge. Security Hub custom actions are initiated manually or by automation triggers, not idle for filtering continuous findings. Let's eliminate it. We'll move to C. If you look at option C, using anything but in event bridge pattern filtering excludes unwanted inspector findings before invocation, reducing operational effort. Let's keep this. We'll move to D. If you look at option D, it says set up an SNS topic to relay findings on to the application. Add a subscription filter policy that rejects alerts containing the product AWS inspector strings. SNS filtering applies post routing and doesn't prevent Lambda invocation or reduce upstream traffic. Incorrect. We'll lock option C as the right answer. So please don't go away. Let's meet in next part of the series.